Hey everyone, my name is Anna Grace, and today I'll be presenting on Trichobatrachus robustus, also known as the hairy frog, wolverine frog, or horror frog. I have my PowerPoint out here with me, and I'll be going slide by slide with you just to present this information. Alright, so just a little background on the general physiology of the wolverine frog, and I will refer to them as wolverine, horror frog, and hairy frog throughout this presentation. They are all the same frog. They're roughly about 11 centimeters in length. They have a pretty broad head to a more compact body ratio. This is one of the only species of amphibians where males are definitely or visibly larger than the females. And when it comes to their coloring, they are olive brown with some black edging on them, except breeding males who have a little bit of a different appearance, which I'll get into a little bit later. Alright, so slide 3 is just some general info on them. Their habitat is from it's humid forest from southern Nigeria to roughly northern Angola. Their diet consists of slugs, beetles, grasshoppers, spiders, and myriapods. And they are listed by the IUCN conservation community as least concern. So their populations are healthy where they're native to, and they don't seem to be any in danger of any form of extinction. Their lifestyle, they are most active and do most of their hunting for their food at night, so they are classified as nocturnal. And they are a terrestrial frog, however they do return to the water for breeding and mating purposes. Getting into their unique physiology on slide 4, I have my first example, which is their claws. These are not our typical claws that we are taught about. Claws that you typically think of, like your cat's claws or your dog's claws, are made of keratin. These claws that the hairy frog exhibits are made of bone. They come out when the frog is either attacked or threatened, and it is bone, like I said earlier, that is connected at a little nodule that's held in place by collagen fibers, and when they're attacked, the nodule breaks and the fiber as well. And if this is the nodule right here, this knuckle, it literally just comes out like this through the skin. They're not very large, however, I do think that they are beneficial when you consider their size relative to their natural predator size. They could probably help ward off those attackers. So when this nodule is broken and the bone protrudes through the skin, they're able to use them as claws that we would think of. There's no known natural retraction, like you think of a cat. The bone kind of naturally either, sometimes they break off, sometimes they just kind of go back in, and then they continue to be active, and then they'll return to somewhat of a normal shape, and then the healing stage begins. This skin that the bone protrudes through just goes through a natural healing process. It's not sped up in any way. It just kind of goes over. I did look into like scar tissue, and this happens more than multiple, probably tons of times throughout their lifetimes. If those specific areas exhibited increased scar tissue, if they would still have this ability, and studies or observational studies that have been done on them, they are still able to do it from the time of that juvenile stage until death. They never lose the ability to break these nodules. But yeah, so I thought that was really interesting. On slide 5, I've included some photos. One is an x-ray where you can see the little bones that protrude. I have some white arrow markers pointing specifically to those parts. And then I just have a normal picture taken. That way you can see the ratio of the claws to the frog's webbed foot. Like I said, these claws are not very large. However, I think that they're still beneficial in cases to ward off the predators that these these frogs have. To compare this to human physiology, we don't have anything like this. I don't know anyone who breaks their bones when they're attacked to defend themselves, so it's very unique, very interesting. Moving on to their second unique physiological characteristic, that would be the hair that we see on breeding males. This is actually papillae that will form on their sides and then the back of their thigh areas. And this is just arteries that increase the surface area, which of like the lungs, and they help increase oxygen uptake. This is especially beneficial during the breeding seasons and mating for mating purposes, but also because these male frogs exhibit parental care after mom is done laying the eggs. He stands guard. He's not as active. And the eggs are in the water, so if the eggs are in the water, he's in the water, in a shallow area. But it helps with those things. It makes them more efficient during the mating season, and also increases the survival of their young because that male is able to sit there and guard them. It resembles hair, which is why they call them the hairy frogs, and it does. I looked at initial pictures of them, I thought it was hair. Found out it wasn't. On slide 7, I've just included some photos where you can really see it, some close-ups. So it's just like little hair-like spikes that protrude from those areas. On slide 7, you'll also see I posed the question, have you ever seen dermal papillae in humans? Or human males specifically? I haven't. This is not comparable to anything that we've discussed about in people. I do know that in certain instances, like when we're exercising, we have internal processes that help us increase our oxygen uptake. However, we do not have any external features like this that would provide the same purpose. So I thought this was also pretty unique. It doesn't make them the most good-looking frogs, but it serves a purpose like any other adaptation. So how does this affect their survival? This increases their survivability and efficiency of themselves and their young. Those claws allow them to have some sort of defense to predators, and then the papillae allow them to be more efficient during the mating season and increase the survivability of themselves during the season, as well as the offspring that they'll soon have. So I think both are beneficial traits. They're just really unique to them. In terms of conservation efforts for the species, there are none at the moment, just because their populations are stable and they're not of any concern. In regards to ongoing studies about this species, I didn't read any so much about the buccal papillae. I feel like that's pretty straightforward. However, the claws aspect, I did find a study where they were looking into the internal processes and cues that allow for the claws to protrude, like the initial break of the nodule, what exactly triggers that. Because in a previous study that this one was looking to build off of, they noticed that this was not on their own fruition. It just kind of happens when they're in a state of panic, kind of like when our fight or flight kicks in. They were just looking to see if it happened the same way with the same signals inside. I don't think that this would be applicable to human medicine or anything that we're doing for people right now. However, I think it would be cool just to understand that it's not something we see. Usually you would think of as breaking your own bones as a method of defense as a last resort. At least I would. In terms of continued education for you guys and resources, all of my resources were pretty straightforward and easy to comprehend, so I've obviously cited and linked them all for you. There's some good background info on them, and just those processes, and the photos that I've used as well are pretty cool, just to give you some insight on what everything looks like, and especially where you see the nodules break, because they're so small, but then you think it's a little frog. So, but yeah, I hope you guys enjoyed this presentation. I hope you have a great night.